All right, so I just went through the coding challenge code from chapter 2 of the textbook and put together a video where I was pointing out some highlights and then spent, frankly, a little too long at the end walking through that code. So this is the video you're watching now. By the time you get about a half hour in, I'm just going to be walking through the code from top to bottom. That may or may not be useful to you. You might want to play it at double speed. But if you are having problems with this coding challenge, then this video might be useful enough that it warrants watching. Throughout, I have little mentions of highlights in the code. We'll talk about that in class today on the 14th a little bit. We'll talk about some of those things. Some of these things we just kind of see as we come across them. Uh, Learning R is kind of like learning English in that there's a lot more to learn than you ever will. My vocabulary is, on the large-ish side for an English speaker, but I only know a fraction of the total English language. Sometimes you come across new words, and in R, you're going to come across new idioms, new ways of doing things. And sometimes you pick those up and they turn out to be useful, and sometimes you can kind of safely ignore them. But I point out some of them as we go through. In any case, feel free to follow along with me in this video. I am kind of chunking out stuff from the textbook without recording and then coming back and making brief comments in the recording. And then, like I said, about half hour in until the end of this video, I'm just explicitly walking through. And at the very end, this might be worthwhile for everyone. I start explicitly going through and talking about how to modify that figure 2.3. I give you some bad examples, but you can find something a little bit more interesting by devoting some more attention to it. And as always, feel free to ask questions on the blog or the Discord or by email, and good luck. All right, let's take a look at some of the stuff from our Manning textbook. Now, the first thing I'm going to do is clone the repository, which, oops, that's not what I want. Let me go back to here. So if we grab this URL, if you already got Git installed, we're going to see a little bit of Git later on in the semester. This is just a helpful way to work. There we go. So I type git clone and then that. I download this and it's going to take all of that data for me. It's obviously got quite a bit. And it's going to set that up in a way that's easy to synchronize with this project here. Now, in your case, you probably just want to go download zip and extract that and deal with it accordingly. But for me, I can now go into Practical Data Science with R 2nd edition, and I can see what we've got. Now, I want to start working with the public use micro survey data. So let's see what we've got here. And by the way, I am working in what is called a bash shell. This is a pretty standard way to interact with your computer if you're using a Linux or a Mac. And it's important enough that with Windows 10, Microsoft has added support for this, although it's been a long, long time since I've used Windows, so I'm not totally sure how to do that. My advice there would be ask YouTube. All right, so let's go ahead and find where I am in here. Data frame. This is not what I'm after. I'm after the start of this section working with relational databases. And right now my goal is just to get this data in. Right? So this is where they're talking about how they got the data. They use services like wget, which is a program for downloading this stuff. Let me just see if that'll work here. I'm going to go to my temporary folder on my hard drive, paste that, and see what happens. All right, cool. So that URL still works. Often these URLs just change over time. But that this works is a good thing. This means that you should be able to basically follow along with the code. or you could do it like I did and just use the textbook version of the data. All right. At that point, we're basically in the spot where we can follow along using this stuff. All right, I'm going to stop there. All right, I am going through this first coding challenge, following along with the textbook, and I have run into my first obstacle. You're likely to see this. This is a relatively easy one, but if you haven't seen it before, it's worth checking out. So I'm loading in these libraries. So DBI, no problem. dplyr, no problem. rquery, I run into this error message. There is no package called rquery, and that just means that I don't have it installed. So to install it, I just run this command. Install.packages, rquery, I run that, and it will install it for me. And then when I come back up to here and run it, it should be fine. Now for something like that, you might be tempted to put that into your script. The trouble is, if you run this script, you're going to have to reinstall it every time, which is going to slow down the operation of the script, and you really don't need to. So if you've got something like that, then you could just comment out that line, and that'll give you some indication of how you solve that problem. But this is the sort of a thing that you're going to come across so many times that it's not really worth sweating. All right, I've run into another little obstacle here. Running this line, view our summary on this stuff. Could not find the function rSummary. So I just tried installing the package. It started working, which is a good sign, and then it said, warning, package rSummary is not available for R version 3.6.3. So that raises a bigger difficulty. So I just searched for rSummary. You just search and you'll find what's going to be relevant to R. So rdocumentation.org is a good spot to look for this. So when I open this up, I find this description of what's going on. It's telling me compute per column summaries and return as a data frame can be an expensive operation. So to me, this looks like what really matters is this per column summary. So let's just take a quick look at what happens if we do this. I believe if we just do summary on DPUS, we get this. It's telling us that we've got lists. So what have we got? We've got this SQLite connection, and then we get this stuff, dlist db. So it's using rSummary because it wants to get out of this database. Let's see if we just put summary. Okay, it's not going to work. So one way we could do this is we could explicitly run a query on this, which is what we're doing here, and then pass that into summary. Now to make that work, let me add another line up here. I'm going to use, what I really want is the Magritte R library, which I know I can get if I just import the whole tidyverse. This line, the tidyverse, it loads in ggplot, forcats, tibble, a whole bunch of different things. So it's just a really handy line. So when we do that, now we can take this line, db get query on this db. So we've created a database by connecting to what we get out of this RDS file. Actually, dlist, I guess, is the list of variables we're dealing with. But we are connecting with a database. We're writing that database out of the data we pull out of this RDS file. Don't worry too much if this is, over your head. Although actually, you know what? This is really what I'm after. So if I look at dlist, we've got this large list, 280 megabytes. So we really don't want to get at that directly, but we want to see what is in essentially this part. SS16PUS, this is what we're calling DPUS, and this is just part of this microdata that we're looking at. We got all these different variables. So finding this column by column summary, we're going to be doing things like getting average values for the serial number, or actually that's as a character. So that's just going to give us counts. So this is why they're using R summary, because when we run this through summary, it's going to show a lot of data. But as long as I'm doing this, let's try and get it sorted. So I want to call out of this. I want to select all, the asterisk. This is a little bit of SQL that we're looking at here. So this is not strictly R, but this is just another standard language for interacting with the database. Select all from DPUS, and I'm going to limit to 100. So very similar to this line up here. So I'm going to pull that out, and then I'm going to pipe that into the next thing. So this line 23 is giving me a bunch of data, and then I'm just going to run that through summary. So let's see what we get. Cool. This looks about like what I expected. And it's just telling us all this stuff is in character format. This is not really a useful summary. This is really just telling me that all of this data is currently encoded as text, not as numbers, not as factors, not as anything else. It's just a whole lot of text, which is fine. But we'll keep following along with the example. But just be aware, sometimes as you're going through this stuff, you run into these obstacles, especially these things where it's calling for something that isn't operational in the version of R that you're using. So sometimes you can find some workaround. Sometimes that workaround is like the one I'm doing, which is not very great. I could find a way to install and run an older version of R, and that might make this a little bit better. But that's a lot of extra work just to try and figure out one line of code that's just a summary. So for the time being, I'm just going to write that off and just kind of be comfortable with the fact that sometimes not everything goes super smoothly. All right, a little bit more digging has found, I hope, a better option. So install rquery. Wait. Oh, you know what? rQuery, that's fine. So what about this? Couldn't find function rSummary. All right. So rSummary was supposed to be in the rQuery package. And the way I found that, let me show you where I was, and then I'll do a little bit more digging. So on rSummary, it's from rQuery 1.4.4. So I've got rQuery, right? I installed rQuery. I got that latest version. So I was excited just a second ago because I went and I said, let's install rQuery, immediately having forgotten that I had already installed rQuery. That said, when I go to the rQuery documentation, when I look on this page, can I search for rSummary? rSummary is in here. So let's go to the later version and let's search again. So rSummary still apparently exists in here in 1.4.5. Let's take a quick look and see if we can't figure out what version. We're looking at rQuery 1.4.5, so this should work for us. You can see that rQuery, well, I kind of skipped over this, but on the help page for rQuery, it was describing what that package is about. So someone put together a bunch of code for us for allowing us to work with databases. And fundamentally what we're doing here is we're running rSummary, connecting to this database that we've set up on the table called DPUS. Right? You could think about this if you got an Excel spreadsheet. You're going to have tabs in the bottom of the screen, and this is a tab going to a table of this relevant data. So this is what we're trying to do. This should be available. 4.5, this is how to use it. Let's just try this one more time. Could not find the function rSummary. Am I mistyping this? Our summary. No, this. All right, this is just being a jerk. All right, so that was not as helpful as I was hoping it was going to be. So again, sometimes you run into these things and it just doesn't work for you. When that happens, sometimes you just say, you know, I'm not going to worry about it right now. I'm going to keep working through what I can do and come back to this later. So to make note of that, I'm just going to, whoops, so I want comment at that line and just say not working with my version of R, and maybe I'll fix that later. This I can get rid of. Wasn't super helpful. All right, I'm going to keep going. I'm going to see what problems I run into. All right, so I have gotten through the example code in the textbook, and I ran into a problem that I've already shown you before, which is I had to install a package. But as long as we're here, as long as I've got this and I'm setting up this video, let me walk you through some of the things that I'm observing here, some interesting highlights. You know, this is the equivalent of on the left-hand side, you'll see Mount Rushmore. So that last little problem I ran into is I had to install the package wvplots. That one went fine. But as long as we're here, let me show you a little bit of our syntax. When you see this double colon, what R is telling the, well, what you're telling R with the code is there's something in the package wvplots called scatterhist that we want to use. So it says, look in this package for this function. Now up above, we explicitly load in stuff. So if I were to do something like call in library wvplots, and I load that in, this code is still going to work. When I run that, it's still going to generate this plot, but I could get rid of this first part. Okay, now, the reason you might want to explicitly say which function it's from, rather which library you're using code from, is if you're using multiple libraries and some of those libraries use the same names for some functions. So maybe dplyr had a function called scatterhist, and you wanted to use the one from wvplots. You would explicitly use it like that. But that little bit of syntax, that's not urgent, but something to keep in the back of your head. This tapply, this is part of a family of functions we're going to talk about at some point in this semester. The tidyverse equivalent of this is the map family of functions, but apply is really important. Getting good at using apply is how we really leverage this concept you read about called vectorization. So let me show you a non-vectorized thing. It's somewhere in here. This is a for loop. So this is one of our basic ways to interact with data or code. You tell the computer for something in some other thing, we're going to do some third thing. Right, so this is a really simple for loop. It creates a temporary variable called CI, and you can see on my workspace that the current value of CI is WKHP. So go ahead and remove that, just so you can see how it's working. So we're saying for CI in this vector. Right? We've concatenated these 4 strings together, these 4 bits of text. And what we're going to do is we're going to say CI equals AGEP, right? So when we're running this code within these curly braces, we're going to initially say CI equals AGEP. So we're going to say DPUS. That's going to look at this list, or rather it's looking at this data frame, but it's taking the element AGEP from that, right? So that's going to explicitly call a column the AGEP column. Let me just show you that down here. If we do DPUS AGEP, we're going to get all those values. And these values look the same as what we've gotten here. It emitted 36,000 entries. It just showed us the first 1,000. It's 37,000. That's just too many numbers to look at. So that's the bit of code on the left, and then we're saying as numeric, and it's the same thing. right? So what we've got here, well, that's already numeric, but we're going to be converting all this stuff to numeric. Another way we could do the same thing is with the dollar sign, right? That's going to give us the same fundamental thing. But let's just stick with what they've got in the book. We don't need to futz around with this. So when we run this for loop, initially we're saying AGEP, and what it's going to do is it's going to take all of this, right, this data in this data frame, and it's going to replace it with this as numeric, the exact same data, right? So this already says num for numeric, but when we get to the next one, let's just go ahead and explicitly label CI as, oh, you know what, that's already numeric also. Oh, I know why this is doing this. Let me reload this in. So when I reload in this data, it's going to take a little while because there's a lot of data, and we're not going to have that numeric already in there if this ever loads. Sometimes this will happen to you. Okay, that wasn't too bad. You briefly saw, go ahead and pause and go back, but you saw this little stop sign. If your code is stuck in a loop and it's going on forever, sometimes you just want to hit that to interrupt it. Or you could type Control-C or Control-D. These are two old school ways to interrupt what the computer is doing. So you try any three of those to get it to stop if it's running too long. In this case, it was running a while because we're dealing with a big chunk of data. All right, so we've got DPUS. Right now, we've got 203 variables. What this is doing is it's going to take DPUS and it's going to give it DPUS. This little bit of notation we're going to see a lot also. We've got these square brackets. So let's just show it to you in this form. The number, we've got two numbers, one before the comma, one after the comma. The one before the comma tells us the row, the one after the comma tells us the column. So here I'm looking for row 1, column 1, and it gives us value P, this first value. I could also say let's take row 1 and let's take all the columns from 1 to 5. And now we're getting the first row, we're getting those first 5 columns. So what we're doing here is we're saying take all of the rows. If you have a comma and a blank to the left, it just says all the rows. There's going to be too much data, but let's just go check it out. So it gives us the first 5 columns. And that's not the only way to do this. This is just the base R way. The textbook, as you saw, talks a little bit about that. And then this says, give me the columns that match the things in this vector. So we've got this vector of column names. And if you get a typo in there, you're going to run into some sort of a problem. But in this case, it's just going to say, let's go ahead and run this chunk of it. Make sure I'm doing this right. There we go. So that just ran DPUS, all the rows, these explicit columns. And let me add one more thing. So you saw this function view, and that's going to be really useful in RStudio. That just puts it into this table form up here. It's a little bit easier to interact with. You can search with it. Yeah, you can sort it. You can manipulate the data and just kind of fiddle with it and see what it is in view. View is good for viewing, but it's not really good for working with the data except to see what's there. You don't want to actually be making changes by hand. You want R to be making those changes for you so that you can automate the process and replicate your results. So this is the data that we're going to be assigning back into the variable DPUS, right? So right now we have 203 variables. So we're explicitly saying now we're only concerned with these 8 variables. Now we're building back up to this for loop. So over here, when we're looping through this, age P is just 06 as text, right? It is the same as, well, let me see if I can show you this. So if I go 06, and then on a separate line, I go 06, you see my syntax highlighting. Here it's yellow, here it's orange. Orange, given my color scheme, is telling me that this is a number. Yellow is telling me that it's text. You can add numbers, but you can't add text, right? So if we were trying to add stuff, if we were to say, okay, let's try 5 minus 2, error, we're trying to subtract non-numeric arguments. If we say 5 minus 2 like this, it just gives us the actual result. So the current form of the data is going to be problematic. Let's get rid of this. So this for loop is just saying for each of these column indexes, right? CI, this is ultimately arbitrary. We can put this, we can make it whatever we want. So we can change it to dumb name. We just have to make sure we change it in all places. It's going to do the same fundamental thing. You'll often see I used as the variable, the temporary variable in this for loop. We're going to say dumb name takes the value AGEP. We take DPUS for AGEP. Let's go ahead and clear a little bit of space. And actually, let me go back to CI just to, I don't need to make this point. So CI is going to be AGP. We're going to say, let's take the HP column out of the DPUS data frame and let's replace it with a numeric version of that. So when we run through this loop, it's going through and it's changing all of the initial things, all the things where it can work. Why are they not doing this with, oh, I know why. It's not doing it with cow because we aren't explicitly putting cow through the loop. So it says for age P, for PRN, PERNP, PINCP, WKHP, for these variable names, take that variable column and replace it with a numeric version of itself, and that's going to let stuff work. Now, I was building up to talking about apply and vectorization. A faster way to do that would be to use an apply function or a map function from tidyverse, and that's something where it's not always super easy to figure out how to write the code. When you write the code, it ends up looking really nice. It ends up being a little bit clearer, a little bit more readable, and it usually runs a lot faster. The advantage of a for loop is really good for just prototyping. It's really easy to put together a for loop. It just runs slow. Apply, the apply family of functions and vectorization, these are really important when you're dealing with really large amounts of data. In this case, we're looking at 5 different columns and changing the entire column to as numeric. So actually, we're running a for loop, but the actual operation, the real meat of this, is already vectorized. Right? So let me show you an unvectorized version of this. Let's see, comment that out. For here, I could say for row in DPUS CI. So let's go ahead and look for each row in that data. Let's just call it I. For each individual unit in this data, we put in our curly braces. We're going to execute this bit of code, and we really just want I to be as numeric. And then we want to replace the element in here with a numeric thing. Actually, now that I'm looking at this, it's not going to actually work because R is looking at this age P. Initially, it was looking at it as a character column. That is a vector, and vectors all have to have the same data type. So these are all numeric, or they're all character, or they're all factors, or they're all integers. They're all something explicitly the same. If we were to go through this, we would be saying, let's go through each column, and then let's go row by row and replace each individual value. Right? That's just not going to work because it's going to keep throwing errors. But this is essentially, well, it's still a good enough demonstration of a poor implementation, to say nothing of a non-functional implementation. So this already is kind of vectorized, but we could have vectorized, oops, that's not what I wanted. We could have vectorized a little bit more and vectorized going through these 4 columns. But for 4 columns, the amount of effort in coding, you know, if it takes you a while to look at the right stuff, to look things up on Google and to sort it out and try some things, it takes you half an hour and it saves you a half a second, probably not worth doing. Although for educational purposes, by all means, go for it. So let me do a once over from the top. All right, so from the top, I didn't actually need this line. I added that just to make sure that I had access to this piping variable for when I was fiddling around with the R summary problem. But let's not worry about that. So we're loading in some libraries. That's calling in explicit data. I've added one more library, that wvplots, to make that point earlier about calling this function from that library. Now, quick digression on R style as compared with other programming languages. In other programming languages, you might be expected to make it really clear that this is coming from that wvplots library. In R, it kind of varies, right? It sort of depends. You'll figure that out as you go. You know, you'll pick it up just through practice. But in any case, we could explicitly load in the library, and that's going to load in a lot more functions than just that one. Since we only really wanted that one function, we could have just done what it did in the textbook and explicitly called wvplots : and then the other thing. All right, so dlist is loading in fundamentally this large list of 2 things where they've already set up the data for us. This is the textbook authors. So read RDS is calling an RData object. And like I said before, some of the stuff it's going to be over your head right now, but it's good to see it so that later on, when you're ready for it, you've seen it before. So we get that large list. It's got a lot of data, 280 megabytes. That's something where if you loaded it into Excel, it would just really bog things down. Your computer would be glitching. You really don't want to be doing that. This is one of the places where R really has an advantage. You can work with a lot more data at once. You can work with bigger data sets than you can in Excel. All right, so we create a database. And in this case, we're just creating it in memory. We're not explicitly creating a database on our hard drive. We're just creating a temporary database. We're running that data from dlist into that database so that we can work with it as a database. Now, partly this is just educational so that you can see what it's like to actually work with a database. And part of that is it's just going to make it a little bit easier to manipulate these large amounts of data all at once. Although we are going to kind of pull that back out in the end. So here, again, some database stuff. We're running a query, which means we're asking a question of the database. So we say, hey, database named DB, this one we created up here on line 9. Select everything from this table called DPUS that we created on line 10, but just give me 5 items. Right? So that's just looking at the database. We're not actually doing anything here. We're not saving anything. This is purely exploratory. This isn't necessary to do the coding challenge to get this function, to get this plot operating. Here we're creating a table. We're looking at this again. Right? So this is, we are loading in the table from the database. And again, we're looking at the data. We tried R summary. If you're using an older computer that loaded an older version of R, this might have worked for you. If you got a newer computer and a newer version of R, you ran into that problem, but don't sweat it. I'll look at that in the future. Maybe I'll figure out how to use it, how to update it so that I can use that code as it is. All right, so we're explicitly making these bits of data, these data frames. Let me close this so we can see what it looks like, you know, without seeing the details of what's going on in each part. So we load in that data from our database. We explicitly call just these columns. We're throwing out all those 200 columns to only look at these 8 that we're interested in. We are changing some of those columns so that they're numeric. You see here this warning message, NAs introduced by coercion. And all that means, let me do this really quick. I'm going to create a different thing. This is bad. Do as I say, not as I do. This is not a good idea, but just to see why we're getting these NAs, I'm just recreating this object with a slightly different name that's not going to interrupt with my work below. All right, so we've created this backup version. We've explicitly made that just the 8 columns. Let's get rid of that. We don't really need the backup version. And then let's just go head of dpus.back. So when we tried to convert, let's see, WKHP, I think this is something to do with work. This is a 6-year-old who doesn't work and has a kindergarten level education. So when we try to convert this bit of text, we say as.numeric, NA, it converts it to an NA, which is a type of data that says not available. Right? It's sort of an empty spot. It's not a 0. It's just saying whatever's supposed to be here, it's not something that makes sense. Right? So 6 makes sense. You're going to convert that to a number. It's just going to be 6. There's not a number you can map that to. Right? So if someone said, someone left their age form, the age field on a form blank, you can't say that they're 0 years old. You could maybe say that they're the average age of everyone just as a placeholder, but in R you just say, well, there's nothing here, right? So you say NA. Cool. So we create this data frame. We make some of the columns into numerics. We do this string trim. So let's go ahead and look at this cow data a little bit more explicitly. So dpus cow. We're going to get a whole bunch of stuff. So we're getting all these long descriptions, employee, blah, 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 blah. It's nice to have that when we need to go back and interpret stuff. So for example, if we were to make these dots colored in based on this stuff, we want to know expected income as a function of age. Do older people make more money than younger people? Which is what we're seeing here, but maybe we say, let's account for the nature of their work, right? Are they working for a for-profit company or do they work for the government? That might affect things. This line 34, this is just saying, this is too much text. Let's limit this to only 50 things. So let's do that. And let's go ahead and take a look at that again. And this is a little bit easier to work with, right? It's less explicit. We're throwing away a little bit of information, but this is something we should be looking for in the code book. All right, I'm not going to look at the structure. That's going to show me the whole thing. And then I've got some stuff where I'm saying, hey, this thing, employee of a private for-profit business, let's remember that that is one of the things that we want to treat as a factor. So a quick note on factors. Factors are a data type that are helpful if you're looking at categorical data. We're starting with just text data, right? So we just have this bit of text. There is this file, and somewhere in the file, well, a bunch of places in the file, it says this. And we want to treat that not as just sort of this string of text, but just saying this is a category. Call it category 1. All right, so we run through all this stuff. We run that. We check the complete cases. That's going to get rid of things that have too many NAs. And then width is a cool thing. We'll see width Well, we'll see how much we see with. I used to use with a lot when I was in grad school a million years ago. I use it a lot less now. But using DPUS, we're doing some stuff, right? We're basically looking for the places, we're looking for all of the workers who make more than $1,000, who are civilians, who are making less than $250,000. Right, we're just running through some conditions. We're saying that their COW, whatever that is within one of these things. Right, so we're just, don't worry too much about that. Try and read it, but don't spend too much time confusing yourself on this. We run through this. We're explicitly calling just the rows where this is the case for all the columns, all 8 columns we have left. And we're telling it not to drop things. This is an interesting little bit of code in here. Square brackets basically tell us we're going to slice a part of this data table. In this case, we're keeping certain rows, we're keeping all the columns. So we can do some cool coding in those square brackets, basically to select parts of a data frame. The tidyverse way of that would be to do something more like this. So let's see, can I do this? I'm going to run everything above this. Control Enter. Run that. It's going to take a little while. So if we were to take DPUS, let's make that pipe a little more explicit. Pipe that into filter. We want to filter for where we have complete cases. And for that, the code, the textbook authors have just said, we're going to make this thing. Let's go ahead and see what complete looks like. It's a Boolean vector. So it's saying out of 100,000 rows, which ones are complete. So we're just going to take that. I believe we can just plug that directly into filter. And then also standard worker. And actually, I think we want both like this. So let's see what we get. Go to here, run that, and we get a bunch of rows. Now we're getting a bunch of columns too. And actually, let's do one more thing, because this is tough to work with. We're going to pipe that into view. And here's what we get. We get 37,111 entries. These are all the entries that meet those 2 conditions. They are complete, as in they have data for all the columns, and they fit into this standard worker classification. So standard worker is basically saying, out of this data table, who has these conditions? So you have these conditions if your value for Pince P is greater than 1,000, and this is the case, and this is the case, and so on. If you're in 250 with me, we are talking about this as symbolic logic. This is just an AND operator. So it's saying, out of the people in here, who has an age greater than 18 and less than 65, and their work hours per week is greater than 30, and their principal income is less than $250,000, and all these other things. And it's going to tell us that that's false for the first worker. I believe match, is match going to work for me here? So if I go match standard worker, I think this will give me, I'm not going to worry about that. Let's just look at the head of standard worker. Most of them are false. Let's try sample n, standard worker, we'll look for 15. All right, let's make this explicitly a as.data.frame, standard worker, 15. There we go. So we'll come back to the code in just a second. All I did here is I use sample n, that's from dplyr. I took standard worker, this Boolean vector, I converted that to a data frame. I said treat that as a data frame, and then give me a sample of 15 random rows out of that. And so you can see some of them are true, some of them are false. Let's actually go ahead and take that and let's pipe this. Let's see what happens if I just run it through me. I get NA. What about if I just say, I take that and I multiply by 1. Dot not found. All right, what about as dot numeric? No. Sample and, well, whatever. I'm not going to worry about that. So these are things that you should experiment, you'll play around with. What I was hoping to do was take a sample like this, convert false into 0, true into 1, and then figure out how many as a proportion were in there. Now we know we get 37% of our complete sample, or 37% out of our rows. So let's see, we got 1, 2, 3, 4, 5, 6. So that's a very small sample. We got 6 out of 15, which is a little more than a third, which is about what we got. So our sample there was pretty good. It could have been a smaller number of trues. It could have been a larger number of trues. But this is stuff that you might do while you're experimenting. While you're exploring the data, looking at some random rows. 15 rows is a really small sample, so it's not really a thing to be trying to figure out the average number of standard workers out of that, but in any case, let's see this. We don't need, oh, did we do that? Yeah, we ran that into view and we got this. So that is the same thing as what's going on here. All right. And then there's a bunch of stuff where they're combining all these different things. So first off, it's saying if you have an NA value in your school field in that column, or this pipe sign, which on your keyboard should be off to the right past the square brackets and the curly braces, you'll see a backslash, and then if you hold shift, you get the pipe. Pipe means or. Double pipe is a vectorized or. But here we're just saying for each individual row, if you have an NA or you have this condition, which is a bunch of stuff, and all this stuff says your school value is in this list, in this vector. So the value in this thing, we look at your row in the data, and do you have an associate's degree? Do you have a bachelor's degree? Do you have a doctorate degree? Whatever your value is, if it's one of these things, then this bit of code evaluates to true, and the exclamation sign negates that. So it says not true. So if you have an associate's degree, then you do not have no advanced degree. That was too many negatives, but in any case, we're saying if you have an associate's degree, we don't want to count you as not having an advanced degree. So not having an associate's, bachelor's, doctorate, or whatever, or having an NA, those are the rows we're going to consider no advanced degree. Right? So here we are looking at, we've already simplified DPUS to the 37 rows, so we're getting this Boolean vector that says, for example, rows 1, 2, and 3 have no advanced degree. So let's go ahead and look at the head of DPUS, and we can see, is that right? True, 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 false. That doesn't seem right. No advanced degree. That's a little weird. I think we haven't, oh, you know what? We haven't called this line of code. So we run that. Now we've got 37,000 observations. Now when we run this, we're rerunning this. This was left over from before I started rerunning stuff. This, by the way, is a problem that you'll run into sometimes. You'll be working with your code. You're going to be going back and forth between the console and the script. And it's really easy to solve something one place and not the other and kind of get things mixed up. In this case, this script is good because we're working on tested code from someone else. They've already done the hard work for us. But in any case, just be aware of that. Be aware that it's really easy to maybe do something down here and forget that you've still got 100,000 rows because you forgot to run this line up here. All right, so we ran that. We create this, or we recreate this, and now we're seeing true, true, true. So let's again check the head of DPUS. And we've got 1 or more years of college credit, 11th grade, right? So this person doesn't have an associate's, this person doesn't have a high school degree, this person has 1 or more years of college with no degree. Here we've got someone with an associate's. So our 5th row of no advanced, we've got true, 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 false, true. False, true. This is, sorry, no advanced degree. So the person with the associates we're saying has an advanced degree. The person with the GED we're saying has no advanced degree. All right. So this bit we are creating, or rather we're replacing all of this. So when we run this, and let's go back and look at this again. Now we've got no advanced degree instead of grade 10. Associate's degree stays as associate's degree. So all of these rows where, or all of these elements of that column SCHL, school, if they have no advanced degree, then we put in the value no advanced degree. If we have a false in this vector, then we just leave whatever's there. Another way to do that would be with a call to if else, which is a handy little function. So we could say if else school equals, say, associate's degree. If that's the case, then we just leave in school, and otherwise we put in not associates, right? Something like that. But we'd have to do a bit of coding in order to get that to work properly. So if this works, we're happy with this. Now this re-level, this has to do with dealing with factors. So when you're dealing with factor data, let's just really quickly look at summary of DPUS. School is currently a character. When you're dealing with, we'll do it like this. We'll do as.factor DPUS $school. We're going to see here are these different factors in this, these different groups. Now, let's say we invented a new category, like say a trade. Someone has, someone's a carpenter, or a plumber, or an electrician, and we wanted to include that as, to distinguish them from just, say, a high school dropout. And we wanted to find out, for example, does an electrician make more than someone with a doctorate degree? So in a case like that, if you wanted to add in that data, you'd have a hard time adding it to this data set because we've got this list of factors and it says here are our 6 categories. And if you say here's a 7th category, you have to explicitly tell it, let's add that 7th category. So in this case, they are being explicit about adding in these different categories and setting the levels appropriately. We'll come across that as we come across more categorical data later in the semester. Let's not worry too much. So we save our data to this RDS file so we can reload that data and have our work already done for us later on if we want. Running a summary on that, we can see how many people have no advanced degree versus doctorate versus whatever. We see our male-female breakdown and how many people didn't put in a value for there. Seeing how many NAs you have is a really valuable thing you can get from these summaries. With the age, we can see we're missing a lot of ages, and of the remaining ages, we've got between 18 and 65 with an average age of 41.3, median of 41. That's kind of interesting. That's a little bit more symmetrical than I might have expected. All right, back into the code. We're going to column bind. cbind means bind by columns. You also see rbind for row bind. We're going to take the data frame where we are converting school back to a character. We're explicitly not calling strings as factors. So you read about this in the book a little bit. We're combining that data frame with this model matrix. So let's run that, and let's see what it looks like. So now we've got, oh, this is really cool. So this is something, like I said, you learn, you keep learning. This is good for me to know. This is what's called a one-hot encoding. And you actually saw that term used in the reading also. So this is creating dummy variables where it's saying either have 0 or 1 for each column. So this first person doesn't have an associate's degree for school. They don't have a bachelor's degree. They don't have a doctorate degree. They don't have a master's degree. They don't have a professional degree. They just have this intercept. This is someone with no advanced degree. Cool. We're going to replace that intercept with null, and we're going to look at the structure of that. So this leaves us with a data frame where we're keeping the school column where the degree is going to be some value like that. And then we've got these columns of 0s and 1s, just like here, where the first person with an associate's degree is this person here. Now, another quick thing that I'm seeing here that's worth bringing up is we have row names. So let's go ahead and go back to, do I still have dpus back? I do. This is good. So if I go dpus.back, which I created, you may or may not have, and I look for row 68, what I get is a 58-year-old who works for a for-profit business who has an associate's degree. So what's happened here is this data frame D has kept row names. So we've got column names and we got row names. Now, in this case, that was really helpful for going back to the unsorted data, the 100,000 observations, and checking our results here against what we started with. In the tidyverse, it's not recommended to keep row names. You definitely don't want to be storing information in row names. If you need to save that information, so let's pretend like this was, say, a name, you would just explicitly have a column called name. If the data is important, you want to give it a column. Row names are kind of like a secret column that's just a name for each row. And that's fine, right? It's not necessarily getting in the way, but just be aware that's what's going on here. This is telling us, row number 68 from our original data. We never rename that. So this is our 5th row in the data frame D, but it was row 68 in our original thing before we started doing this filtering, before we started getting rid of the people who were, kindergartners. All right, we run this table. Table is really helpful for breaking down what we've got. And depending on how far we get into I'm looking for, into models where we're categorizing, classification models. If we get into classification models later in the semester, we'll use a special type of table where we look at how far off our predictions are when we look at some data set. A convolutional, is it convolutional? Well, whatever. We'll talk about that when we talk about it. We get a table, so we're just looking at that. And again, tapply, part of the apply function, is a really good way to set things up, especially when you're dealing with a lot of data, but it is a little tricky to figure out. The apply functions kind of take a little effort to learn. You get better if you use them a lot, I personally don't use them daily because, I'm teaching most of the time. My class is not a whole lot of R, so I usually just end up having to have an open tab in my browser to figure that out. And finally, we have recreated the default plot from the textbook. Now, I want you to try and modify this. So let's go over to over to the browser. We're going to look for WV plots. Go put this here. Search for WV plots in R. We find the page. You can go to the R documentation page. You can go to the example page. But we'll just see what we've got. You'll see this sort of a page a lot. So in this case, let's go to the GitHub. That's probably a better place to go. Yeah, let's go there. So, oh, here's the reference manual. So sometimes you'll go there. Let's just go to the GitHub page. We'll see what they've got. So this is actually where their code is for this package. And usually they'll give some useful thing. All right, let's go to the website. Right, this is the website. All right. So here they've got some descriptions. They'll have some documentations in here. So this is where the stuff is that gets loaded when you search for help. Let's actually go there. So we got this. And actually, what we really want to know is not for the package as a whole, but for the scatter hist function. So if we go through here, we can see what we're actually getting. I'm going to rerun this line of code. It's going to open up the plots. I'm going to come back to the help. And you know what? I don't need to see what's in my environment. Let's just get this whole thing. So we got all kinds of things in here that we can change. So our frame is the DPUS data frame we were dealing with. Our X variable is age. Our Y variable is income. Our title is expected income. That would obviously be a super easy thing to change. Let's look, what are our columns in DPUS? So let's just change one of these. Let's change this to COW. And we won't fix the title, but let's just see what we get. Not meaningful for factors. COW was a factor, so let's actually just quickly summary. Actually, here's where structure is good. Structure of DPUS, so if we change principal income to WKHP, and you run that, oh, come on. Yvar must be the name of the column. WKHS. WKHS is not WKHP. Typo. No big problem. All right, we're on that. Now we've got a slightly different version of this plot. It's plotting out different data. Actually, interpreting that is going to be a little bit trickier, but you can see we've got a lot of data where people are saying they worked 40 hours per week, which maybe is the case, maybe is a lie. We got a few people working 80 hours per week. But now we've also got this relationship between their age and how much they work. So you can basically see by the time you are in your late 20s, the expectation is that you're going to be working, well, a bunch of hours. Or actually, sorry, let me rephrase that. In this data set, we have not many people in their early 20s. We have a lot of people in their late 20s and older, and by the time you get closer to 60, we have fewer people in the data set. People start to retire. All right, so you can fiddle around with this stuff, and you can figure out, for example, how can you rework this function so that it shows us something about how is age and work hours related, right? So you can try and create a graph that makes sense of that. So you might want to put work hours on the x-axis. I'm going to just empty out this title, and then we might put age over here. right? So you can fiddle around with things like this smooth method LM. This means it's running a linear model. It's doing a regression in here. So in this data, and be aware, the data is really sparse for more than 60 hours a week. Very few people seem to record working more than 60 hours per week. But the people who do, on average, seem to be a little bit older. Right? So this is giving us some indication that as you get older, you're going to be working more hours per week. If you are, well, this is not a very good regression. But in any case, that is a very brief modification to this code. Now, I've been going on way too long, so let me record an intro to this video, put it all together, and warn you that this is kind of a lot of stuff. In any case, go for it. It's relatively straightforward. You might run into some problems. For example, I ran into this problem, and in some cases, you can just skip it. But basically, if you type out the code in the textbook line by line, you run it as you go to make sure you're not getting any typos, you can get down to here, and then you can fiddle around with this and try and figure out these relationships within this available data. You could go back and not restrict ourselves to these 8 variables, right? So you might add in another variable based on reading the code book and seeing what you think is interesting. But we'll talk about that later. Good luck.